energy. Usually when you're burning stuff, it's got heat. So it's going up. The rain washes it down. So it's trying to fight its way up. The rain washes it down. Well, then what happens when the rain blows by? There it is, up into the upper levels of the atmosphere. This is where, remember we were talking about the energy coming into the earth from the sun. It's higher energy up here. So the energy hitting your pollutants up there is causing these chemical reactions to happen. So it's not the same as being down there on the surface of the earth where your car is. This is like being up there above the clouds where the planes are. So the big thing about the Concorde is the Concorde's flying way up high there. That's where all the exhaust is coming out. So the reason it can fly so fast is it gets way up there where there's less resistance because the atmosphere is thinner. Well, the pollutants are going right into that higher part of the atmosphere where they do the most damage. Now this, I got to admit, I've talked to some Berkeley chemists and they get pretty vehement about their discussion of the ozone hole. The ozone hole, I believe, is related to the ionosphere. It's the way that the Earth is moving, the charges, how much radiation is coming from the sun, and the hole is over the southern hemisphere. So this may have something to do with, I think, that the land, Antarctica, is there. In the ocean up there, remember I said all those particles that are hitting the Van Allen radiation belt are redirected to our poles if they're not blown out into the plasma sheet. So when they come into the Earth in the poles, I think you got the protons coming one side, electrons on the other. Well, this is where the ozone is a real thin layer way high up there. So the ozone is what's getting what they call depleted. So this was in 1986. This was about the heyday of the argument. So we didn't really have anything to compare it to. We didn't know what the quantities were. It's time of year that things go different, the seasons of it. So here we are roughly in, is it going to focus, 1982 was the size of it, 1983, 1984, I guess you can see the darker blues getting bigger, 1985, and now look at the deep, see there's not even a deep purple on those early years. It's like no purple or blue. Now you get light blue. Well, now look in 86, the deep purple. So all within the scanning time of 5 years, this is what they observed. The ozone was really depleted at the South Pole. Okay, so this I guess is the outline of Antarctic. So what they would be concerned about, I guess, is like this here. What do you got? Green, yellow. So yellow's about the border. Brown ain't bad. Where, this is South America, Antarctic. Where, I'm looking for Australia. So see Australia here, they're showing it in the blue on the sides here. So the ozone is really getting depleted. So some people believe the chlorofluorocarbons are creating that. Others have their doubts. Now this I want to just show is that when you've got to understand what the weather is like. This is the Gulf of Mexico. Here's Florida. Some maps never show. Look how big Cuba is. All our maps make Cuba look like it's real tiny. Cuba's huge. It looks bigger than Florida. So here's a storm. This was in 2004. This was Ivan. And right behind Ivan was little Charlie. Behind Charlie was Jeannie. I remember Jeannie. And then Francis. So look at these hurricanes. 4 of them right in a row. All behind each other coming into the Gulf. So this was 2004. Here it says hurricanes slam into Florida, one after another, in this composite satellite image of storm tracks of August through September. 2 of the most active months of Atlantic cyclones on record. So these were actually overlaid. So this was September. This one was August. That was September. And that was August. So you kind of had this one, and then the next week came that one, and then 2 weeks later came that one, and then Ivan. But here's Florida, so it was catching Florida was the deal. So we're always going to have Mother Nature to contend with here. So see the air. This is what the air looks like. Very delicate, fragile. You seen the shell of a hard-boiled egg? Well, this is the thin membrane underneath the hard shell on the outside of the egg. Did you ever pick some of that apart? That is what the Earth's atmosphere is like. We need to protect it. Now we're going to talk about the pollutants. This was a good little model here from National Geographic I picked out from 25 years ago. So obviously nobody is paying attention anymore to this. So we'll just go through here and show some of the pollutants. Arsenic, that's a metal. Carbon monoxide, nitrogen oxide. Now you've got mercury, cadmium, those are heavy metals again. So all three of those, arsenic, mercury, cadmium, heavy metals. These are our atmospheric ones. Actually, nitrogen could be included in the heavy metal. Atmospheric molecules, these are the ones we're going to make in a minute here. Carbon monoxide, nitrogen oxide, sulfur dioxide. Silicon 4 is tetrafluoride. H2S is considered a pollutant. Hydrogen sulfide, rotten egg smell. HCHO, this is why we're going to make the molecules. This, I believe, is formaldehyde. Cl2, chlorine gas. So what are these called? CH, and I guess those are just unburned hydrocarbons, they'd call them. C6H6, it's probably benzene. Okay, so they did this good here. I guess these are the lower atmosphere ones. Smog. Now they use red for higher energy. This is pretty good. Whoever did this knows what they're doing. Ozone, O3, NO2. This was NO, lower atmosphere one. Up here, now nitrogen dioxide, HONO. What's this one called? We've got nitrous acid. Ooh. Pan, I don't think that's Peter Pan. That is a pero. Hey, look, pero. What's a pero? Pero's a dog. So we're going to do some with that. That's going to be a dog. Peroxyacetyl nitrate. Well, that's probably too big for us to make. OH, that's hydroxide. H2SO4. There used to be a poem kids knew. That's sulfuric acid. Here again being the black, this must be metals. Heavy metals again, arsenic, mercury, cadmium, nickel, cadmium, lead, manganese. What else is down here? These are gases. CO is carbon monoxide. F, that's metallic fluorine if it doesn't have the minus on it. See, minus here is a fluoride anion. That's the big difference I talk about. One electron makes life possible. Chlorine, poisonous gas. Sodium, an explosive metal. Sodium gives up the electron. Sodium chloride. Salt. Cells need it. Your body needs it. What do we got here? HF, hydrogen fluoride. Get that with water. You've got a strong fluoric acid. It'll etch glass. You've got SO2 again. So these being black are going to be low atmosphere, heavy metals coming out of the smokestacks. Then higher atmosphere are these red ones. This is really a good drawing here. These are gases now. Over here you got the black again, so these are in the atmosphere, in the soil, in the water table they call it. So I'll read these just to show what it says here. Arsenic from coal and oil furnaces, glass manufacturing. Arsenic. Glass manufacturing, long-term exposure may cause lung and skin cancer. Benzene, C6H6. Benzene says is from refineries, motor vehicles. Long-term exposure may cause leukemia. That's your blood